In this video, I'm going to explain you about Newton-Raphson method for solving fx equal to 0. So in this method, like in bisection method, we have taken two approximation in the beginning of the method. So in this method, we'll take only one approximation and we try to find the root of the function fx. So in this one case also the function should be continuous. So I'll explain you with the diagrammatic structure of this. So what you do here, suppose this is your x-axis and y-axis, this is your x-axis. Suppose you have a curve in this way, and I have given you the initial approximation. This is your initial approximation that is taken as x0. So at this point you can find the value of the function. So this value of the function at this point is nothing but f of x0. So the point at this point is nothing but x0 comma f of x0 will be x0 comma f of x0. At this, the coordinate of this point is nothing but x0 comma f of x0. So you draw a tangent at this point. Okay, so if I draw a tangent at this point, then this will cut the x-axis at this point. So this point, let us take as x1. Then we try to find what is the value of the function at this point. That is nothing but x1, f of x1. So again you try to draw a tangent at this point. So I draw a tangent at this point. So I get another value x2. Then I'll draw I try to find what is the value here. So it is x2, f of x2. So you go on proceeding in this method, then we come closer and closer to the roots. Okay, so we come closer and closer to the root and we get the approximate value of the root. So in this method we can find the approximate value of the root, but one more thing you have to remember, that we have to choose the initial approximation properly. If you don't choose the initial approximation properly, you will not get the approximation of the root. So when you have to choose the initial approximation, you have to be very careful that you can get the approximation root of this function. So this way we are going to do. Then we'll try to find how to find this x1. So this is a tangent. So we'll try to tangent is nothing but a straight line. So we'll try to find the equation of the straight line. So equation of the straight line passing through these points. Okay, so equation of the straight line passing through this point. That is what we have formula as y minus y naught. Y naught is nothing here in this case. Y naught is nothing but it is f of x naught. So we have here y minus f of x naught divided by x minus x naught. So here we have x minus x naught, which is nothing but equal to the slope of the line. So the slope of the line is the first order derivative at the point x naught. So we have here f dash x naught. This is the first order derivative. Then from this you get here as y minus f of x naught, which equal to f dash of x naught, x minus x naught. Okay, since to find the root it should cross the x-axis, so y coordinate will be 0. So if you put y equal to 0, you take y equal to 0. If I put y equal to 0 here, I get here what? Minus f of x0 equal to f dash x0, f dash x0. Here we get x minus x0. You bring this one this side, so we get here minus f of x0 divided by f dash of x0, which is equal to x minus x0. So in this way we get here what? X minus x0 equal to minus f of x naught divided by f dash of x naught. So bring this x naught to this side, so we get x equal to x naught minus f of x naught divided by f dash of x naught. So this is the second approximation. This is nothing but the second approximation. So in this way only we can write, if I write second approximation as x1, So x1 will be equal to x naught minus f of x naught divided by f dash of x naught. So if I write the ith iteration, so the ith iteration will be given as xi plus 1 equal to xi minus f of xi divided by f dash of xi. So this will be the iteration formula for finding the Newton approximation method. Okay, so I'll do one problem here. So this is the iteration formula here. Also I have derived the iteration formula, so in that way we are going to use this formula now. So the geometrical representation also I have explained you, so we are going to do in that way. So from here, now we are going to solve this question. Solve cos x minus x ex equal to 0 by Newton's Raphson method, and we have to take x0 as 0.8, this which is your initial approximation. So in Newton Raphson method, the initial approximation will be given, or you have to choose an appropriate initial approximation. So here we have taken x0 as 0.8. So I take the function fx to be cos x minus x ex. Then I'll differentiate this f dash x. So differentiation of course is minus cos is minus sine x. So we get here minus sine x. This one you have to differentiate by product rule. So first of all I'll differentiate ex. So I get ex. Then I'll try to differentiate x. We get nothing but 1. So we get minus ex. So I think you know how to differentiate by product rule. So you get by that. So I try to find what is f of 0.8. So f of 0.8 I got this. Then f dash of 0.8 I'll put here, and I'll try to find, I'll get this one. So I'll use this formula x1 is equal to x0 minus f of x0 divided by f dash of x0. So you put these values and you try to simplify, you get 0.571. So in this way you can find the next approximation also. I take x2, then here will be x1 minus f of x1 divided by f dash of x1. So x1 we have got already, here we'll put 0.571. So we got here 0.571, so we'll use that value. So here also 0.571, and we'll try here also we got 0.571, and in here we're trying to f of 0.571. We'll try to put this value and we get this minus 0.167, and in the same way we'll put in f dash also the value, this value, so we get here minus 3.321. So after that if you divide we get here 0.051, and if you minus we are getting here 0.521. So this is your second approximation. Then you try to find the third operation. So 0.521, then you try same way you put this value here, then we get minus 0. Then here also you put, so you get this, so you divide this to we get 0.002, and if we minus this to we get here 0.519. So this is after third iteration we are trying to write the approximate root. So if they give to you till fourth iteration, so you can proceed till x4. If they give you till third iteration, so you can just proceed till here, and you can find the approximation root. So what will be your approximation root after the third iteration? In this question, the approximation root of fx after the third iteration is nothing but x3. So x3, how much we got? We got as 0.519. So this will be 0.519. Thank you.